First of all, I'm surprised to see so many people up early, on a Thursday morning. Clearly, it has to be a developers conference. If this was a marketing or sales conference, nobody would be here, right? They'd be in Santa Cruz.
This is your East Coast crew here.
I'm from East Coast too, so you can't sleep, right? Yeah, I'm in a hotel, and I didn't realize it. The train is right next door, and the first BART arrives at 6:20 sharp. So every day I wake up at 6:20. All right, I think we can start now. We're almost at time, and I see the room filling up. So. Folks, my name is Rupin Mohan. I work for Hewlett-Packard Enterprise, and I'm part of the storage and networking team. And so I'm going to talk about NVMe over fabrics for the next generation data center. So kind of focus on where we see the trends are going in terms of the data center, and then how the fabrics piece will fit in. So I like to have a little bit of a chat with you guys. So I'm not going to kill you with 45 slides. I have about maybe 15. So we have a lot of time to have a chat, right? So they like to keep it interactive, so I get to learn from you also, okay? So with that, the agenda that I have in my mind today is talk about trends a little bit, and then go into the concept of what does this new I/O stack look like, in this next generation data center, especially around NVMe and NVMe-oF fabrics, right? And then the concept that I'm thinking about, I'm calling it a simple invisible fabric, right? And I'll go into a little bit more depth in that. But the idea that I have is, that in this next generation data center, the network is going to become very key because of the way we think it's going. And then, of course, we'll share some performance data that my team has collected, and then some thoughts over next steps, right? I mean, this is something that, all these things are my input, is not Hewlett-Packard input, so keep that in mind a little bit. Okay, so what does disaggregation mean, right? So one of the big things that's happening in the data center is disaggregation, right? And it's a kind of a loaded term. Last night I was having dinner with some folks, and they asked me, what do you think, what does disaggregation mean, right? So I built this slide, honestly, on the flight from Boston to San Francisco. So I was thinking how to simply put it on a slide rather than make a complex slide with a lot of stuff in it. So what I came up with is very simple slide, right? And on the left side you see compute racks with top of rack switches connected to a fabric, connected to a storage array, right? That's your data center today. You talk to customers, your customers. I think 80 to 90% of the customers will have something like this, right? They could have, different sorts of network topologies, star, mesh, core, edge. They could have, 2 or 4 top of rack switches. They could have end of row switches. They could have core switches. But this is where, the data center is today. Another thing that I see, especially in the enterprise, is storage is often an island, right? Generally speaking, storage arrays are in one section of the data center. Especially when you look at the big enterprise, right? You got the core switches, next to the storage arrays, and then all the servers are all over the place. And for all the mission critical apps, they're, for storage access, they go into that one area where all your big iron is, right? And then that storage pod, you may call it, or whatever, is replicated, sometimes 2-way, sometimes 3-way, easy example I give is, New York, across the Hudson River, right? There's a site A, in Manhattan, and then the site B is across the river for DR purposes, and then there's this, third site, where they're doing some async, right? So that's your sort of your, data center today. Where, I think the data center is going in the next 5-10 years is this whole disaggregated, data center where you have network, storage, compute, sprinkled all across. and that storage island, where all the storage arrays are, that kind of goes away. And you have, different customers will have different architectures, but basically think of that the compute, network, storage are sort of spread across, and sort of fabric becomes kind of from the piece that connects, compute to storage, it becomes kind of where the fabric is, where everything is, right? Not necessarily the control piece. The control piece is not, the fabric is not going to control everything, okay? That's not what I'm saying in the slide. But the fabric becomes the foundation of the data center, okay? So even when you double click on each of these components, whether it's compute, whether it's storage, whether it's networking, there's disaggregation happening inside these components too, all right? Now, what do I mean there? Look at the networking piece, right? People are moving towards open standards. They're moving towards, merchant silicon running an open OS, network OS, like Cumulus, for example. Like a lot of those customers are looking at that, where they don't want to buy Cisco switches, costing, gazillion dollars, right? They want to buy, switches, and they want to run and they want to kind of disaggregate the hardware from the software, right? Same thing's happening with storage too. I mean, and I'll talk more about that, going along. Storage is becoming really, really fast. I mean, with NVMe, and what's happening there is that the applications are becoming more and more smarter, and they want to do some of the features that traditionally is done by a storage array, right? So the applications are saying, just give me really, really high performance, fast storage, and let me do some of the features that I want to do in my application, right? So there, the disaggregation is happening there. So that's your storage sort of disaggregation, right? And then the compute, I mean, the boundaries between compute and storage. So what is a storage pod? What is a compute pod? I mean, they're all getting blurred, right? So, today you buy a server, it's an x86 server with an Intel or an AMD processor in it, right? You think, oh, that's a server. I think 5-10 years from now, you're just going to buy a pod, and that could be a storage pod, or it could be a compute pod, it could be anywhere in the data center, right? That's where I'm going with this slide. You guys get it? Okay. So my point of view, you can argue with it. So what is this new data center? What are the parameters that will be the focal points, right? Unlimited bandwidth is, I think, one of the things that I'm saying. That this new data center will have a lot of bandwidth, a lot. It won't be 10 gigabits per second. It won't be 25 gigabit per second. It'll have a lot of bandwidth, right? The concept of traffic, okay, traffic goes from my server to my top of rack. I mean, that all things goes out of the water, because I think traffic's going to go everywhere, north, south, east, west. Traffic will be everywhere. It'll be workload driven. This new data center will be workload driven, meaning customers will say, I have a certain workload. That's the right pod I want to put this workload on, because that's the right piece of hardware that is needed for this particular workload. Okay. Low latency. Latency will be key, right? And that's the beauty of NVMe. What we've been doing in NVMe in the industry in the last 3-4 years is we're really basically beating down on the latency, right? And you've seen several presentations this week where everybody's talking about benchmarks are becoming critical. Latency, is we're trying to reduce latency in the whole stack. And I'll talk about that a little bit. Software defined also is becoming like this. Part of the reason why this is disaggregated is becoming more and more software defined. Doesn't mean that our hardware solutions are going away. There's a very clear distinction I want to make here. There's going to be a ton of hardware innovation that's going to happen in this industry. And the hardware guys they really do a yeoman's job. I mean, if you look at PAM4, you look at all the new speeds and feeds coming out. I mean, it's becoming a big challenge for the hardware guys to really push the technology to the next generation, right? So hardware is going to have a lot of innovation, but it's going to be sort of hidden from the software. Software will be kind of running and taking advantages of these features that the hardware layer is going to provide. But software is going to become more generic, more open, while the hardware is going to have a lot of innovation, right? Orchestration, automation, simplicity, that's another big thing in this new data center, right? Everything is going to be automated, orchestrated, and it's going to be super, super simple. Because guess what, guys? If it's not, that customer is going to go to the cloud. So automation, orchestration, and simplicity is going to be key for on-prem data centers because they have something to compare with. It's going to be scalable, right? I mean, it's going to have to scale. The reason why you had the storage in one area and the compute in another area was for scalability, but now that scale is going out of the water. Now people want even bigger scale. Industry standards are going to be really important, right? Because if you want to disaggregate, you're going to have to be more industry standard. If you want to aggregate, it's going to be more proprietary, but if you disaggregate, it's going to be more industry standard. So industry standards are going to be more important, SNIA is going to be more important, SDC is going to be more important for all of us to get together and chat, right? And the security piece, right? Security is key and is the foundation of this whole story, right, is security. And I think one of the things that we do at Hewlett-Packard is we really, really focus on security. And that's actually, we have root of trust. The security is an area where we kind of really win. And then the last 3 points in the bottom are also really important points. It's hybrid cloud, right? So if you look at the cloud market, right, it's about, let's say, 200 billion, 180, 200 billion, right? But the overall market, the tech market, is about a $2 trillion market, or higher, right? Depending on what pieces you count. So cloud is really less than 10% of the market today. Okay, that's just a fact. Okay, 90+% of the server storage, networking, and the services associated with it, et cetera, market is on-prem today. I don't believe that 80% of the market is going to be cloud. I believe that on-prem is going to have a very strong place. But I think where the sweet spot is going to be, it's going to be hybrid cloud. Okay? That's where the sweet spot is going to be. It's going to be the hybrid cloud because customers are going to be, every customer will have certain workloads they're going to run on-prem. They're going to have certain workloads that they're going to run on the cloud, depending on their application, depending on their business requirements. Right? The key there will be business requirements. Because whatever, customers and spend money on IT because they want business results. They don't buy the new servers because they're cool, right? So hybrid is going to be very key, and there's going to be that's going to be the integration point between the cloud and on-prem, and that's where I think the data centers are going to sort of come together. Right now, the cloud's doing something weird here, and we're doing more traditional, and I think we're all going to come to a nice middle spot, and we'll all be happy customers. The last 2 points are also very important. The total customer experience in this new data center is going to be really, really important, right? Customers, one of the reasons customers like the cloud is they don't have to worry about it, right? They swipe the card, and they kickstart a workload, and it kind of works, and they don't have to worry about firmware upgrades, software upgrades, making sure the cable is inserted, the SFP is inserted properly in the switch or not, right? So it kind of makes life very easy for customers. So we're going to have to deliver the similar sort of customer experience, whether you're on the cloud or whether you're in a hybrid cloud or whether you're on-prem. We're going to have to deliver as an industry the same customer experience. Where customer says, okay, here's a check. This is what I want. These are the workloads I want. These are the workloads I have. These are the applications I'm running. I want this type of an SLA, and here's a check, and you have to deliver it, right? And it's going to have to be super simple. It's going to have to be super simple. And then the last thing is all the cost of ownership, right? All this magic has to be delivered at the lowest possible cost because, IT demands is becoming so huge that the budgets are not rising as the demands are going up. So we're going to have to squeeze more out of the same amount of dollars. So we're going to have to keep an eye out on the cost. We just can't come up with a solution and say this is great, but the price points are off the charts. So we all have to be, as designers, as architects, design solutions that meet the cost point that the customers want, right? So this is what I mean with this next generation data center, and then I'll go now deeper into NVMe and NVMe-O fabrics. Any questions on this? Okay. All right. Let me go into the, sorry, go ahead.
What do you see as that center fabric?
This is going to be where the competition is going to be, right? There's going to be a lot of competition in the fabric, right? And I'm going to talk about that in my coming slide, because this fabric itself, different parts of the fabric will have, I think, different players and different preferences. But I think eventually it's going to have to be a single fabric, right? From a technology perspective, customers will have multiple fabrics: fabric A, fabric B, backup fabric, management fabric. I mean, like every customer today has, right? They have at least 4 to 5, 6 fabrics. Every single customer: SAN A, SAN B, data fabric, management fabric, backup fabric, right? But in this unlimited bandwidth, you may not need that many fabrics. If you have this simple, high bandwidth network, you may not need to have all these multiple fabrics. You can save a lot of money by having maybe 2 fabrics, A and B. Okay? So let's look at the new I/O stack. And the first thing I want to quickly cover, and I think you guys are pretty smart here, but generally speaking, when I talk to a lot of people, they think NVMe is a new type of media. So I have to kind of remind them that no, it's not a new media. It's just a protocol to access this new type of media, right? So I think hopefully you all get that. And you also know why NVMe was formed, and what's the beauty about NVMe. I don't have to repeat that. It's been talked about many, many times in this conference. So what I'm saying is that NVMe is a new language for accessing solid state media, right? It's a new language. So traditionally, when you look at our traditional storage arrays, right, they're all pretty much running SCSI, right? You have the controllers are running SCSI, your front end's all SCSI, your back end's SAS, SATA, and all the software stack is based on SCSI and optimized for SCSI and fine-tuned for SCSI, right? That's your traditional gasoline engine in your car, right? What is in the market today is what I call hybrid arrays, right? Similar to your gas and electric hybrids that you've been seeing, the Toyota Priuses you've been seeing, and you see a lot of them. Still very popular. That's what you see in the market today. What does hybrid storage mean? What it means is the controller is generally still running SCSI, but you got a back end that's maybe NVMe drives, partially NVMe drives, or full, mostly partial I've seen. And then the controller is doing the SCSI to NVMe translation and kind of taking a little advantage of the drives. But honestly, when you look at the performance charts, you really don't get a huge ton of a performance advantage by using NVMe drives today, given the stack, and I'll come to that. The other implementation is you put an NVMe cache controller in your array, and you put all your metadata in that, take advantage of NVMe, and you kind of have a hybrid implementation. This is also getting very popular. Actually, you get more performance advantage in that today than the drives. But then you have the whole software stack that's still pretty rich because it's still running SCSI. What we are going towards is like an all-electric car, like plug-in hybrids, right? That's where electric plugins. That's where we are going with storage array, where it's going to be like in the next, I would say, end of 2020 and 21, you'll start to see all NVMe arrays where basically, the controller is running an NVMe stack. Everything is front end's NVMe, back end's NVMe, and the software features, though, it'll take 3+ years to get to the same parity level because, the NVMe spec is still under development, and that's just a fact. So it'll take 2-3 years before the parity in the feature set comes along.
But what are the main feature gaps?
I'll get to that in a little bit. But my presentation is not to talk about the gaps in NVMe. To be honest with you, my presentation is around NVMe-oF fabrics for the next generation data center. But we can talk offline about the gaps, maybe after this presentation. So if you look at the I/O stack today, right? This is your traditional I/O stack that pretty much exists in every storage array, a storage application that's running in today's data centers, right? You got your application, then you got your operating system stack, which includes your volume manager, your multipathing, your disk driver, your filter drivers, right? All that stuff is in your operating system stack. And then, of course, the last is your mini port driver or your adapter driver, right? That's your driver that talks to your HPA. Then you connect that to your switch. The switch is then connected to a front-end host port in your storage array, right? And then that storage array, generally you have some cache, and then from the cache you have your controller, and then after the controller you have some drives in your in your disk shelf, in your head shell, which they call, meaning the drives that are inside the controller, and then you have a JBOF or you have a JBOD that's connected to your controllers for expansion storage, right? This is your stack, right? So one of the things that I'm kind of preaching is that the whole stack has to really change to NVMe to take full advantage of NVMe. Okay? What do I mean there? Meaning, I can't just put NVMe drives in the bottom of the stack and say, okay, my storage is NVMe and I do NVMe. That you can do it in your marketing literature, but really from a technical standpoint, you're not an NVMe stack. Your NVMe stack will be when the whole thing, really the performance kicker, the performance advantage of NVMe will show up when every single portion of the stack is NVMe optimized. Meaning the applications are taking advantage of SPDK, the volume manager is optimized for NVMe, the multipathing is also optimized for NVMe. You're using NVMe over Rocky or NVMe over TCP or FC-NVMe. You're using the optimized driver set there. Even on the host driver stack, if you look at the operating system guys have done the same thing. They're changing the mini port drivers initially to talk to NVMe, but the rest of the stack is still SCSI. So even the operating system guys have to go through major OS development, right? And that's why you find today that only Linux is the only operating system that really has a full-fledged NVMe over Fabric stack. Everybody else is sort of backing into it. And I think all the operating systems are going to be coming out next year or year after with the full NVMe stack. The switches are actually, the switches in terms of whether it's a Fibre channel switch or it's an Ethernet switch, actually it's doing pretty good. Both protocols really don't have to do a lot of work to support NVMe, hence I think both are in a pretty good shape. And then you have the cache, and then you have the controllers. The controllers are really where the complexity is. For them to move from SCSI to NVMe, there's a lot of R&D that has to happen, and it's going on right now. And then the JBOF. And this whole concept of JBOF is expansion storage, and that itself is very interesting because, again, going back to my point around disaggregated storage, your JBOF is an interesting piece because it's kind of connected to a fabric. Is it a storage controller? Is it a JBOF? What does it do? What features can that do versus the controller does? The lines are blurring again there. Okay? Any questions on this slide? Okay, I'll keep on going. And then again, the invisible network, right? The concept of the invisible network. It's got to be simple. It's got to be invisible. And that's what the NVMe guys are really doing a lot of work, right? They're trying to get this network latency down to basically being invisible. Meaning, the goal is to, for applications, whether the NVMe drive is inside the server connected to PCIe, or it's in a JBOF somewhere in the fabric, or in a storage controller somewhere in the fabric. Basically, the application doesn't see any delta in performance. So basically, make the network invisible. Okay. So now coming to the earlier question on what will this invisible fabric, what will this single fabric, what will this simple fabric look like, right? So if you guys have been in the storage industry, which I suspect you guys have been for a long time, you remember when Fibre channel first came out? the first implementation of fiber channel, sort of a fabric, or it was arbitrated loop, we would call it, was in the back end of the array. Do you guys remember that? All the drives were fiber channel drives, and they were connected, behind the controllers in a fabric, right? Fiber channel fabric basically became popular in the back end of the array before it came to the front end. So the same concept is coming back with NVMe over fabrics, right? Because what you're going to see is you're going to see servers talking to storage, controllers over a fabric, and then the controllers are going to be talking to NVMe drives over a fabric. Okay, so there's going to be a concept of front-end fabric and a back-end fabric. And again, this is a logical picture. Things could be done, from a disaggregation point of view. Some pieces could be in the controller, some pieces could be in the compute. This is a logical picture, okay? But the point I wanted to make is we have two fabrics now. And the second point I want to make here is that the back end generally leads the development than before the front end because it's a controlled environment, right? You don't have to worry about 15 operating systems, right? You have this single operating system running on your storage controller, talking to a drives, connected over the fabric. The use case is very tightly controlled, so you can make it work much easier in a much easier fashion. And then the next scenario that I want to sort of bring to the table is, you will have this, use cases, in this disaggregated fabric, data center. You'll have all these different use cases, right? And the one thing that I want to point out is that this use case, the number 3, right, where you have the servers talking to these NVMe SSDs disaggregated inside a JBOF, that's where I think where the disaggregation will happen first. And that's the use case, kind of a new use case. So you'll see, vendors will coming out with, storage products, with the third use case, this year or next year. And this market is evolving. Any questions here? Okay. So this is where the, my thoughts are, where which protocol will get first-hand, space, and then how this will evolve. So let's start from the back end of the back end, right? Let's start from the back end. So today, if you look at low to mid-range arrays, PCIe will be a popular fabric in terms of connecting these NVMe drives to controllers, right? So I think PCIe will be pretty popular for a low-end solution, storage solution, right? But as you scale that, I think NVMe over Ethernet, Rocky V2 is going to be the most popular protocol for back-end connectivity. And of course, InfiniBand is the third option, and you have one vendor in the industry who has today, a sort of a back-end solution with NVMe in the market. But that I think is a very niche. InfiniBand continues and will continue to be remaining a niche protocol for a niche space. The controllers, of course, are going from SCSI to NVMe. That transition is happening right now as we speak. And then on the front end, this is where I think you all probably are most interested in. I think FC-NVMe is going to become popular for the next few years at least, because as I was talking to you guys in my presentation yesterday, some of you were there, customers have already invested a lot of money in FC, and they're just not going to throw that equipment away. If you talk to customers, they don't necessarily like spending money on FC. A lot of the customers hates writing million-dollar checks for FC, but they still do it. You know why? Because it works. All right? It's a reliable network. It's a trusted network. It's secure, and it works. So customers keep on spending money on Fibre Channel, even though they don't want to sometimes, but they still keep on doing it because storage is really, really critical for any application, and for them to have that type of an SLA, they keep on spending money on FC. And then I think they're going to take advantage of that investment for FC-NVMe to begin with. Okay? But I think NVMe over fabrics over Rocky V2 is also going to become very, very popular in the data center. And if you haven't taken a look at it, I suggest you do. I think the concept of that single fabric, to your question, I mean, it has to be, the answer has to be Ethernet. I mean, Fabric channel cannot be the single fabric, right? It just can't. So if you look at it from that perspective, Ethernet has to be that single fabric. And with the speeds and feeds that are coming down the pipe, 100 gig, 200 gig, 400 gig, I mean, the amount of bandwidth that's going to be available, it's going to be just awesome, right? And the focus on the latency piece there also. Simplicity also, a lot of focus on simplicity. We have several projects going on. We're going to make this thing really, really simple for customers to use and deploy. And then the last thing is this NVMe over TCP, which is also getting a lot of attention, especially from cloud and CSPs. They are really interested in this NVMe over TCP. But the question that we all are, and we can have a chat, is a little bit is, does it require an offload stack? Do you guys think if NVMe over TCP becomes more popular, do you think it requires an offload card? Or you think it doesn't require? I mean, I like to open it up there. So any thoughts there?
If CPU utilization matters, yes, you need to do it.
Okay. Thank you for that comment, and you grease the wheels a little bit. Anybody else? Come on, guys.
Currently, the Rocky V2 cards, they have offloads. So obviously, if you're going to compete against that for NVMe or TCP, I think you have offloads there.
Yep.
Same with fiber channel.
You need some form of offloads. What they are is still to be.
Okay. Any other thoughts? Okay. It's early in the morning.
One point I want to make
Yep.
is the Rocky V2 actually it assumes a lossless network because it runs over INFINIDAT, right? So there's a distinction between NVMe or TCP. How do you see that? I mean, do you see that that's a big difference here between lossless and lossy networks?
Yeah, I think my personal opinion is, for storage traffic, you need a lossless network, right? So that's why Rocky V2 I think runs over a DCB or a lossless Ethernet network. So you will require some sort of lossless network. Now, if you look at lossless Ethernet network, right, that itself is a loaded term, right? Because you can have a very lossy Ethernet network, and you can have a less lossy Ethernet network, and you can have a a lossless Ethernet network, right? And there are so many different knobs that you can tweak to get from that point A to point B, right? And then you have so many different protocols to tweak. It kind of becomes a challenge from a customer standpoint, right? Okay, I bought an NVMe Rocky V2 solution. Now, how do I configure my network so it becomes lossless? Fiber channel is lossless. It's easy. Fill it, shut it, forget it. I don't have to worry about it. But Ethernet, there's so many different knobs you have to fine tune and tweak. That's where when I said that it's going to have to be simple, it's going to have to be automated, it's going to have to be orchestrated, that's going to be key. Because if you look at customers in general, not a whole lot of customers have that type of networking depth of knowledge that is going to be required to configure this fabric.
Also take an investment at the customer site for that type of equipment and the investment of people to manage it.
That's right, and that's why you need tools.
Yeah.
Because I think customers will make investment in the equipment, but in the people will be a problem.
Fiber channel went through the same thing. If you recall, in the early days, the management of the fiber channel was special people. I myself was driving to customer sites to go help manage them, and I see the same thing happening with the managed.
Yeah, I totally agree with you, and that's why. But I think the difference is the tools and technologies have really advanced quite a bit in the last 20 years. So I think that's where I think we're going to have to make it easy because see, even if you want to spend the money, it's not easy to find people who understand this stuff too. This is a very, very complex area. Sorry.
One of the first steps in a mundane data center to create a lossless Ethernet network is to physically separate the storage network from the front-end network. Say, for instance, if you have deployed a Cisco AIC configuration leaf and spine in the front end, you can't run that
On your storage.
as your storage network. You can create a separate leaf and spine, spend $1 million check
Yep.
or two for that, and then you have to run a completely different operating system, and the Ethernet guys don't want to have anything to do with that.
That's right. That is what I said. That is exactly what's happening today. That's exactly what's happening today. Even if you have an Ethernet storage network, it's a dedicated separate network.
Like Fibre Channel.
Like Fibre Channel. And if you do all the math, you'll end up pretty much spending the same amount of money. I mean, I've tried to do it different ways, and you know.
And you need different
Yes.
sets of skills
Yes.
in the people who are managing your storage network because they've been running Fibre Channel.
That's right.
They haven't been running Ethernet stack.
Yep.
And the guys who are running the Ethernet stack are concentrating on, say, AIC, and you're going to be on your own.
That is why I've been a big proponent that if we're going to have to make this fabric a single fabric and it's going to have to be Ethernet based, we're going to have to make our Ethernet fabric for the storage customers look a lot like Fibre Channel. Okay, so you and I are 100% aligned. I'm buying you beers.
You're using single port connections. You're going to have dual port connections. You're going to go into multiple leads. Every communication from that lead is going to have to go up to the spine if it wants to go anywhere except it's connected onto that same leaf.
Yeah. I think this is where, you know, if you look at it from the next 5 years perspective, right? I mean, 400 gigs, you know, I think using that port level segregation, I think is going to go away, my personal opinion. I think there are going to be technologies available for you to use the same port for two different.
There's still physical path issues.
We'll discuss that offline, but I think this whole concept is going to go in one. Sorry, go ahead.
Yeah, I have a question on the scalability of your backend fabric. So in this picture, what's your optimization points? Like how many, maybe rephrase, like how many switch layers you may have in your backend?
Okay, well, that's a very good question. Excellent. I think in the backend fabric is going to be much simpler than the front-end fabric because you don't have the scalability requirements here, right? How many JBOFs are you going to have behind a pair of storage controllers, or two pairs of storage controllers? So I think you're going to be looking at maybe a single or a dual hop fabric. You know, again, if you really want to go into technical, hop is a different definition for Ethernet versus Fibre Channel, but I'm not going to go there. But think about it, like 2 switches between, I think, are the maximum. You know, you'll see, you know, the back end fabric, but on the front end you can have, you know, multiple hops. Fibre Channel today supports up to 7 hops. Yesterday in my presentation, somebody asked me a question: how does the Fibre Channel network scale? And I said, we have seen Fibre Channel SANs. We see them all day long. Huge SANs, 15,000 ports, 20,000 ports, 30,000 ports, big SANs. So again, I'm not going to beat up on the landscape today, and you know, kind of, I have 10 more minutes left, I think. But you know, you get the picture here, right? I mean, you know, all these different protocols, and I've talked about, you know, I think it's basically, you know, FC, Rocky, and TCP. These are the 3 contenders, and you know, depending on, you know, your requirements, I think you'll be ending up in one of these things, these 3 things. So let's talk about performance quickly, right? And this is a simple configuration, you know, pair of switches, you know, a couple of servers. And then you have a JBOF and a SAN blaze, which is a soft target, right? And what I want to show you guys is just kind of give you guys an idea on what performance numbers we are seeing, right, today, in focusing mainly on the protocol piece, right? Not a particular device or a particular, you know, doohickey, right? I don't want to focus on a particular piece in the puzzle here, but just focus on the protocol and just give you guys an idea on where we are headed, you know, in this concept of a simple invisible fabric, right? The things in the green box are all in the soft target, but I did put a number out there, which is just a single JBOF, Ethernet, Rocky V2 connected, right? And you see that, it's about 100 microsecond latency, end-to-end latency, right? Today, if you look at all the leading arrays, including from HP, we are actually doing pretty good on latency. I mean, our flagship platform, 3-power, you're looking at about a 200 microsecond end-to-end latency today. It's pretty darn, low latency today. But if you look at this JBoF, which is not a finely tuned, optimized, it's, standard industry pieces, about 100 microsecond. Now, let's move on to the soft target piece, right? That's, I think, where the interesting piece is, right? If you just change from protocol from fiber channel to fiber channel, NVMe running over fiber channel, right? Just the switch from SCSI to NVMe, you're going from 60 to 50 microsecond latency, right? And you're seeing this, huge jump in IOPS, right? Yesterday there was a question asked in the presentation, what's the performance with the protocol? So what I'm saying here is just switching the protocol, you're getting about a 15% improvement in performance. That gives you an idea. But the most interesting numbers are if you go down in the last 2 rows, and I just focus on the last one for a second. This is with our HP Gen 10 servers, the new servers we have out there in the market, which are selling like hotcakes. 100 gig with our M series switches that we have also. I mean, look at the numbers, guys. We are at like 18 microsecond end-to-end latency.
The comparison is unfair. You're comparing against 32 versus 100.
No. I'm comparing just. But the latency should not be an issue there from the speeds and feeds perspective. IOPS, yes, I agree. Go ahead.
What do you mean by a JBoF? Because when I think of a JBoF, there's no processor in a JBoF. And so you're talking about a Gen 9 server that has an OS that's a JBoF?
No. Just think of it as a node that has SSDs drives in the back end and PCIe switch and then some sort of smart NIC in the front.
Okay.
Yeah.
So for the fiber channel, are you using Gen 6 or Gen 7?
This is Gen 6. Gen 7 is not out yet.
What's G?
Gen 7 adapters are.
64 to 32 gig. It is last year it was G.
The adapters are available at very high cost.
But they're with 32 gigs optics.
Yes,
So
it doesn't matter for the latency.
Yeah. So the 64 gig optics are not there today, and they're going to be coming out sometime March, April next year. So I have a problem when vendors call Gen 7 when in my opinion Gen 7 is when you have 64 gig. But what they're doing is they're calling the new chip but the old optics Gen 7. Okay, I'm not going to go there because it's an emotional topic for me. But I mean, the point here is, we're looking at, huge number of IOPS and then really, really low latency with NVMe-oF fabrics, and that's what I wanted to sort of, let you guys, give a little peek on. So again, this is my last slide, and some high-level thoughts. Like low latency is going to be key. There's going to be intense focus on performance optimizations, and kind of driving the latency out of the stack. The stack is under development, and every single layer in the stack, as I mentioned, is under development. And if you get full performance advantages of NVMe when the whole stack is there, today you are seeing sort of hybrid implementations out there with a lot of marketing collateral surrounding it, right? I think making the fabric simple and invisible with automation and orchestration is going to be key if you want to deliver that simple solution to the customers who are not very conversant with all these different new protocols. And there's a very steep learning curve to get to that point where you become really expert in it. And the other thing is the tools are going to have to be specifically developed, because after you configure all this stuff, how do you test it? How do you make sure everything is configured right? That's a challenge too, in the Ethernet space. The new storage architectures are in development across the industry, and a lot of talk happening in this forum today, in this conference. And then the NVMe SAN, offers a significant opportunity for us to deliver that low latency, high performance disaggregated storage. Bandwidth and IOPS, I kind of showed you some numbers. They're going to scale really, really high, and applications are going to take advantage of it. Because right now, I think we sometimes doubt whether, okay, I have this really, really low latency, and I have this huge number of IOPS, but how do I take advantage of this? I think, it's going to be like, they're going to take advantage of it. And hybrid IT is, I think, bringing the cloud and the on-prem markets together, and they're going to be more aligned. There's going to be more collaboration between the cloud and the on-prem guys. I think both sides realize we got to talk more, and we got to engage more. And I think the hybrid cloud is going to bring people together. Okay. And then the last 2 points, as I mentioned earlier, total customer experience is going to be the key. We have to focus on the customers. Customers are going to be the North Star. Whether you're designing a solution for the cloud, whether hybrid cloud or on-prem, it's going to have to be with the customer head on, right? And then all this delivered at the lowest cost of full ownership, not just product, but services, everything included, right? It's going to be like TCO, focus on the TCO. So those are my thoughts, folks. Thanks for spending your Thursday morning here. I'll take more questions if there are any. So.
When you were talking about the back end and the front end networks, you had previously said, remember the good old days when the back end produced Fibre Channel first? The reason that you're going after that the design is taking Rocky and discarding Fibre Channels because of lower latencies in Rocky.
And also the drive vendors are not doing Fibre Channel drives. They're all doing so those if the drive vendors started to do, and I think it's just not gonna, we're not gonna go back to 1999, right? It's just not gonna happen. But the reason is it's going to be a fabric. It's going to be Rocky V2 fabric in the back end. But the drives are going to be today they're all basically PCIe. So you have to basically do the sort of a JBOF, right? Or they're in the head shell of the controller. But going forward, they could be Ethernet drives. NVMe over Ethernet. The drives are like in the again. I said the disaggregation. You can double click on it multiple times.
That's a use case for compute inside the drive.
You guys can take this, in your disaggregated data center, right? The thought can go, but we're talking now 10 years from now, I think, 5 to 10 years from now. Okay, folks, any other questions? Thanks, folks.